Hello everyone here, this is Eason from Think Academy Singapore. Today, we are going to talk about Pythagorean Theorem. The Pythagorean Theorem is about a right angle triangle. So if there is a right angle triangle here, we can find that there is three sides A, B, and C, which C, the longest one, opposed to the right angle, is the hypotenuse. And we have the sum of squares of vertical and horizontal side will equal to the square of the hypotenuse. So this is what we call the Pythagorean theorem, right? So there are some typical numbers that can form a Pythagorean equation, which is 3, 4, and 5. 5, 12, and 13. Maybe 7, 24, and 25. 8, 15, and 17. And so these four groups are the most typical, maybe we call it Pythagorean numbers. Also, it is necessary to remember that this is not about the number, it's about the ratio. So 3, 4, 5, maybe just three sides has a ratio of 3 to 4 to 5. They are a right angle triangle. For example, 6, 8, and 10, or maybe 15, 20, and 25, right? So, if in a question we see a right angle triangle, or we see the numbers that can form a Pythagorean group, it may remind us to use the Pythagorean theorem to solve the problem, right? So this is maybe the most important thing we should learn before the special round, as every year there is always one question that is about Pythagorean theorem. So let's look it out. So the first question here is the 2019. It's a 5-point question. About the Pythagorean theorem is always the 5-point question, right? So it says that there are two triangles. So actually, two triangle with the same length of side, which is 10 centimeters. As it's given as the square, right? And then we know that the whole area has the area of 125. We need to find the length of DE here. So this question is, of course, a difficult one. How to solve this? First of all, let's look at this area. So the whole area of the figure is a 125. So what can we learn from this? Maybe we can see that there are two squares overlapping, right? So if two figures overlap, we can find the area of the overlapped region by use the sum of these two figures minus the extra area they cover together. So together they should be 200, but they only covered 125 because the difference, there are 75 centimeters, square centimeters, is the area of the overlapped region, right? So we can get this is the area of DCEH. Now we get the area of the quadrilateral in the middle. Then what else should we do? Then we should maybe think about this is about square. For square, they are of a high symmetry, so which means if we draw a line of CH here, the figure is symmetry for the left and the right of the line CH, right? So, for the symmetry reason, we should have that CEH and CDH, they share the same area. So which means we can find that CDH and CEH both has the area of 37.5, right? So now we know the area of a right angle triangle, and one of its side is just 10 centimeters, the side length of the square, right? So then we can use the area to calculate the length of DH. So which can be calculated as 2 times the area and divided by the length. So this will be 7.5. Now we can see that for triangle CDH here, so this is right angle triangle. We know that one side is 7.5 and another is a 10. So we can use the Pythagorean theorem to calculate the hypotenuse, which can be easily found that 7.5 is 3 times 2.5 and 10 is 4 times 2.5. So which means CH 3, 4 and the hypotenuse should be 5 units, right? So it's 5 times 2.5, which is 12.5. So we get the length of CH. But what about DE? We know that I mentioned that there is a symmetry in this figure. So as DE are the symmetry points, so DE should be perpendicular to CH. Then for quadrilateral whose bias is perpendicular, we can see that the square of the area of CDEH can be calculated by the product of CH and DE and then half. So this is an area formula of a certain quadrilateral. Then we know CH, right? We know the area of CDEH. Then we can calculate out DE. So DE then should be the area of CDEH times 2 and then divided by CH is 12.5. So which means it will be equal to 12. And that is the answer. So in this question there are some key points, 3 key points, right? So first of all, we should calculate the overlapped area CDEH. Then we should use the symmetry to get the length of DH, and we get DE and CH are perpendicular. And then the last thing to do is to use the Pythagorean theorem to calculate out the length of CH. Then we get DE here, right? So this is not an easy question for us to solve, right? But maybe in the recent 5 years, this could be the most easy question, easiest question for us about the Pythagorean theorem. Last year, the 2022, there are another different type of question that asks us about a certain figure which we call the hypotenuse diagram. And in Chinese, we call it 弦图, which 弦 means hypotenuse. The hypotenuse diagram is about a square and a right angle triangle. So there are 2 figures here. So each, we have a larger square, a smaller square, and 4 identical right angle triangles, right? Actually, in both figures, we have the side length of the square to be just the hypotenuse of a right angle triangle. And these 4 identical triangles forms another squares. So whose length can either be the difference or the sum of the 2 sides of the right angle triangle, right? So this figure is of a high symmetry as all the right angle triangle here are equal. So and this diagram is often used to solve problems. So when do we need to use this hypotenuse diagram? So you see the figure, right? So firstly, there should be a square, or maybe not necessarily a square. Maybe the half of the square is a isosceles right angle triangle, it will also do. So a square, first of all, we should have a square or isosceles right angle triangle. And then we should have the side of square or the isosceles right angle triangle, to be just the hypotenuse of another right angle triangle. So the first is a square or a isosceles right angle triangle. Then we should have its side to be the hypotenuse. If we fit these two conditions, then in the figure we may use the hypotenuse diagram. We may use its symmetry to solve some difficult question. So the typical scene is just the 2022. So this is the last question here. So we have in this figure maybe 3 right angle triangles, right? So BEC, CDE, and ADE. So we know B is 12, the B is 20, and C is 52. Then here we can just calculate out BC, right? So use the Pythagorean theorem. So just do not use the square. We see the ratio here. So 20 and 52. This is 5 times 4. So this is 4 times 13. 13 times 4. So it's 5 to 13. Then what about the other side? It's 5, 12, and 13, right? So BC should equals to 4 times 12, which is 48. So first of all, we calculate this out. But the question is to ask us about the area of ADE. We should find AE and AD separately. So how can we do this? So in this figure, now it's a typical hypotenuse diagram, as we find a isosceles right angle triangle CDE, whose side is just the hypotenuse of another right angle triangle ADE, right? Now this is what we called maybe the preparation of hypotenuse diagram. So to solve this, maybe we should complete the hypotenuse diagram. As we have DE one side, then we move to the other side CD here, right? So we can turn this ADE 19 degrees and make it to the other side, maybe in F here. F is not used, right? And F here. So for symmetry reason, we should get AE here will equal to DF. So maybe AA here. Then AD equal to CF, maybe a B here. So by then, we complete this hypotenuse diagram, or at least the half of it. But when we complete this diagram, how can we solve the problem? Then we look at the figure. So the figure now is completed as a rectangle, right? So for the rectangle, we have its width and length. So for length here, right, BC and as well as AF. So AF is equal to BC, which means AF is an A plus B. Then BC is a 48. So we know the sum of A plus B. Then for the width, on the other hand, so left we have the width is 20 plus A, and to the right is just a B. So which means we can turn it into B minus A should be 20. Then we know the sum of AB and the difference of AB. We can just simply solve out A and B, right? So by adding the sum and difference together, then minus A, then divided by 2, right? So B will equal to 34 and A should be 14. And then finally we should find the area of ADE, which is simple by the product of A and B minus 2. So it's 34 times 7. So it's an 8 and 238. So this is the way we solve this problem. So the hypotenuse diagram is very important. We should master this as, for some questions, it may seem very difficult to solve it in normal ways. But if you use the hypotenuse diagram, you use the symmetry, you can easily find the answer. So that's all for today. Thank you, and see you tomorrow.